Let's recap part 2 of distance time graph. In front of you, there is a distance time graph. Note, on the x-axis time is given in hours, while on the y-axis the distance is given in kilometers. Imagine Hamdam cycles from his house to his friend's house 10 kilometers away at constant speed. It takes him 30 minutes. He waits there for 30 minutes before continuing to his school, which is a further 6 kilometers away, and he arrives at 3 p.m. He stays for an hour before returning home. He gets back in at 5 p.m. What you have seen is the formation of distance time graph documenting Hamdam's journey. The line A to B shows him traveling away from his house. As this is a straight line, it shows that he is traveling at constant speed. The flat line B to C shows that his speed is 0. He is not moving because speed is found by dividing distance by time. On our graph, it is represented by the steepness of the line, also called the gradient. To calculate speed from the graph, we need to measure the gradient. We can do this by selecting the 2 points we want to find the gradient between, then finding the change in distance and the change in time. Let's try to find the change in distance and time for the highlighted line. We can see the change in distance is 10 kilometers and the change in time is 30 minutes. 30 minutes is same as 0.5 hours. To find speed, we divide distance by time. So we divide 10 by 0.5. This gives a speed of 20 kilometers per hour. We can do the same for the section C and D. The change in distance is 6 kilometers with a time of 30 minutes or 0.5 hours. 6 divided by 0.5 equals 12 kilometers per hour. So slower than part AB. This tells us the steeper the gradient of point on the graph, the faster the speed of the point. The flatter the gradient, the slower the speed, with completely flat line having a speed of 0. Where the line is in downward direction, the gradient is negative. This shows the direction of travel is opposite, such as back home. To work out the speed, the change in distance is 16 kilometers, with a time change of 1 hour. So Hamdam is traveling at 16 kilometers per hour. If the line is curved upwards on the graph, it shows a change in speed and acceleration, meaning speed is increasing over time. If the curve is flattening off, this also shows a change in speed, a deceleration, meaning speed is decreasing over time. We see an angry bird being launched into the sky with a slingshot. Initially it was at rest, but not anymore. Its speed increases as it is launched. In other words, it accelerates. Later, it starts to move at a constant speed and eventually strikes a rock, which causes it to decelerate. As its speed decreases, it still continues to move until its speed becomes 0. Now let's assess the likely shape of distance time graph for the bird. On the x-axis we have time and on the y-axis we have displacement. As the bird was launched, it accelerates and its speed increases, meaning gradient is non-constant, and we get a line curved upwards. Now, when it moves at constant speed, its gradient is also constant. We get a straight line. Later, when the bird hits the rock and starts to decelerate, its speed decreases, meaning its gradient is non-constant, and we get a curved line flattening off. When the line is parallel to x-axis, the speed and gradient is 0, and the bird is at rest. Now, if the bird moves back to its original location, it will move in the opposite direction. Initially, it will accelerate. As its speed increases, we get the following upward curved line. Later, when it is moving at constant speed and we get a straight line, the bird then slows down as it approaches its starting point and we get a curved line flattening off. So if an object moves at uniform speed, the gradient of distance time graph is constant and the acceleration is 0. In such instances, the graph we get is a straight line. The line with positive slope shows the object moving away from its starting point, while the line with negative slope or gradient shows the object returning to its starting point. It is negative because object is now moving in the opposite direction. So if an object moves at non-uniform speed, the gradient of distance time graph is non-constant and the object is either accelerating or decelerating. In either case, the graph we get is a curved line. If the speed is increasing over time, in other words, object is accelerating, then the graph is curved upwards. This shows the gradient is increasing. If the speed is decreasing over time, in other words, object is decelerating, then the graph is a curve flattening off. This shows the gradient is decreasing.